So let's give ourselves a little room. And equation number 5. Always make sure that you wrote this formula down correct, as there's a lot of errors that are made on simple things like this. So, all right, and all we have to do is just plug in our information. As you see over here, we have our 0 times 0.62. This is going to equal to 0, so I'm just not even going to have that anymore. So we have 0 is equal to 1.5 plus, hey, let's just do this thing in the calculator right now. So we have 1/2 times the 0.62 squared, and we get 0.1922 and times our acceleration. Okay. Now, we're solving for our acceleration. We have this term over here, and we have another term over here. Let's get a by itself by getting rid of this positive 1.5. How do we do that? Subtract 1.5 on both sides of the equation. Okay, so now we're here. Now we have a multiplication of 0.1922. So how do we get rid of a multiplication of 0.1922? Divide both sides by 0.1922. And that gives me a negative 7.804 as my acceleration, and that's in meters per second squared. Okay, so this is what we calculated for our acceleration. Hey, wait a minute. Didn't the reading before tell us that the acceleration is supposed to be negative 9.8 meters per second squared? Okay, so it's in the ballpark. Okay, so we could say that we did a pretty good job over here. Perfect? No, I wouldn't say so. But yeah, I think that this is pretty good. So how come we didn't come up with negative 9.8? Well, first of all, what is this negative representing? Isn't the object falling down? So this is representing the direction of the acceleration downwards. Okay, so why didn't we get this answer? Why didn't we get negative 9.8, which is what the scientists actually calculate? Well, I was doing this experiment by myself. I didn't really have any help, not to be making excuses or anything like that, but I wasn't using the most technical equipment, and there's human error involved here. Maybe I didn't start the stopwatch or stop the stopwatch at the right times that I should have, and maybe there was just a little bit of error involved right there. All right, so let's do another experiment right now. Let's see how much I was off. So obviously, the only part that really could be off is the idea that this average time is incorrect. And I want to calculate that. I want to see what the time should have been. Let's calculate out our time. And let's use the negative 9.8 meters per second squared. Okay, so what time should we have gotten? If we still don't care about our final velocity, aren't we still going to be using the exact same formula and just trying to determine our delta t? Well, yeah, so let's do that. So I'm just going to erase all of this right in here. Our final height is still 0. Our initial height is still 1.5. Hey, that didn't change. Our initial velocity, hey, I'm not throwing the ball up or down at all. I'm just letting it go. Times our delta t. What should we have calculated here? Usually when I do have a multiplication of a negative number, I will wrap it in parentheses just so that it's not looking like 1/2 minus negative 9.8. I think it's a little bit easier to read if that's the case. So right here, I have 0 times delta t. Well, we know that 0 times any number is equal to 0. So I'm just going to cross that out. And all we're left with here is this. Let's simplify this. What's 1/2 of negative 9.8? Oh, it's going to be positive times a negative. Positive times a negative will give us a negative number, right? So it's going to be negative 4.9 times delta t squared. Okay, so now let's continue to solve this out. We want to actually isolate our delta t squared. Keep in mind that this is delta t squared. Okay, so how do we go about doing that? Let's subtract 1.5 on each side of the equation, leaving us with this. Okay, and now we have a multiplication of negative 4.9. So let's divide negative 4.9 on both sides of the equation. We'll have a negative 1.5 divided by a negative 4.9, so that will result in a positive answer. And we have 0.306 is equal to our delta t squared. I don't care what delta t squared is, I want delta t. So how do we get rid of the squared? Let's take the square root of both sides of the equation. And this will give us our delta t. So what should we have gotten? Let's take the square root of this, 0.55 seconds. That's what we should have gotten in order to calculate out this acceleration of negative 9.8 meters per second squared. So it looks like, hey, you know what? Maybe this number wasn't really our outlier. Maybe it was this one. I didn't really consider that. I kind of wonder if we would actually get a better answer if we were to have said that our 0.66 was our outlier. Or what you could actually do here to get a better reading is you could actually take not just 6 recordings, but take 20, take 40, take 50, take 100, take 1,000. If you increase the sample size, your accuracy will become a lot greater. Think about this. By us using 0.62 as opposed to 0.55, that is 0.07 seconds of a difference. Go into your stopwatch and try to see what 0.07 seconds looks like. And it is such a small difference. Even using the wrong outlier to cross out, I think that we did a pretty good job here. Having a difference of 0.07 seconds, that's not bad.